Loopr AI, our company. I'm Eric. We've implemented AI into the area of quality inspection and quality intelligence utilizing Microsoft technologies. Overall, our platform is focused on automation of visual inspection of everything from incoming parts and materials to things throughout the manufacturing process, things that you make, things you build, produce, all the way through final assembly, final inspection, and then have the intelligence from the wealth of data that you create during those inspection processes available through kind of Power BI, Copilot intelligence type solutions. Growth of your company can never really outrun the quality of your processes and your production. It ultimately will hold you back if you have problems with incoming parts, incoming materials from your suppliers. During your production processes, you have a number of defects. Not only does that cause extra costs from scrap, rework, and delays, but also as those escape out into your customer environment, it tarnishes your reputation, creates a lot of churn of bad customer will, people sending things back, your team's having to process those warranty claims, pay those out. So, overall, continue to improve your trajectory, keep up with your sales engine. Hee-Jung shared, kind of Microsoft's view of manufacturing and some of the environment challenges. What we see with a lot of our customers is, typical environments. There's increase in, high mix. Customers wanting more customized products. Could be a single customer wanting their configuration for their product. You see with cars or, rockets for different governments that they have their very specific requirements. And, that becomes an increased challenge for your production teams and your inspectors. A lot of inspections are still done manually. And as, the product coming down the line is different than the next product comes down the line, it's very challenging then for inspectors and operators to keep up with. I put in, we're talking some of this morning, I put in a rivet. Is it the right rivet? So even some of those variances, does it have the right mirrors on the side? Does it have the right headlights, the right, labeling stickers that they've seen the same one come through 5 times. The 6th one comes down. They're still thinking about the one they just saw, and people make mistakes. So, the more that we can apply automation across, whether it's a cell or production line, the more we're able to overall increase quality. We see a lot of senior inspectors retiring on the entry level end. It's hard to find people, hard to retain them. So there's a lot of kind of continuous turnover of knowledge and knowledge loss that ultimately can be codified and made consistent. So a lot of lost opportunities also around siloed data. So we'll definitely see a lot of industrial engineers very focused on their production line, or a supervisor focused on their pod, their shift, and they may tune it very well, but their peers across the same function or the same line other places or upstream, downstream, a lot of times aren't sharing knowledge. There's a lot of data that gets siloed without that global view. And also having that siloed data, you lose traceability. Something gets produced and it becomes an input to your product. You produce something else, you've got multiple different steps, makes it out to your customer. Customer then has a problem. Where did that problem ultimately, what's the root of it? Is it your upstream supplier? Is it multiple steps that you have? Is it that it was actually fine when it left your dock? But somewhere in the supply chain further downstream, it had a problem or the customer broke it. Well, without good visibility across that entire supply chain, it's hard to understand the warranties, and you're open to exposure because everyone can just claim it's simply your fault. If you want to make right by your customers, you take that extra expense. But once you unify all that data, you then have visibility and traceability of where errors occur. We had one incident where there was a customer that makes recreational vehicles, and they were doing manual inspections, and a dealer said, hey, we received one of your RVs. It doesn't have the side awning. And the customer initially was like, that's absolutely wrong. We have 5 people that checked off that side awning was on. So, clearly we're not going to honor this. And they had actually just, before working with us, had just implemented cameras to take 4-angle views of these big RVs, pull up the image, and lo and behold, no surprise, there's no side awning, even though 5 people had manually checked the box. So we also see a lot of that of, you have 400 things to check off, people just start checking boxes, and you lose, not from bad intention, but just, human nature. People kind of get in that mode that you lose a lot of consistency and quality without automation. So, we see a lot of challenges, a lot of good faith effort of how people are trying to tackle their quality issues. Everything from just accepting the status quo, we've always done it this way. It's a big headache to fix it, so we're just going to go as is, all the way through performing spot audits. If it's a high volume, we'll pull out every 100 part or material, do a quick check, and then just keep running. And if we start seeing a lot of these 1% that have problems, then we'll stop the line and look for other issues. So to kind of do some spot audits, see people rely on a fixed camera, try to do some basic machine vision, take some images, helps with some of the basic, but very much a point solution. Frankly, we were talking to a customer this morning that she highlighted they're a union shop and the union agreement does not allow fixed cameras in their facility. It's not even an option, but we'll see people try to do some basic integration of cameras with their manufacturing systems. They'll start trying to digitize some of their manual inspections, might even upgrade their back-end technology, manufacturing systems to try to modernize and get a little bit more, might capture some more data, but ultimately they're getting suboptimal. So data is still very siloed, still have those inconsistency issues of inspectors having their different thresholds, people retiring, new people coming in, having data still very siloed. Computer vision can be very good for a specific use case, but oftentimes it's still limited to something that's very simple and very repeatable. Does this bolt look the same every single time? But you start having multiple angles or any variance, you start having issues there. And those models that people are building oftentimes start to deteriorate. Camera can get bumped, color of the materials of the parts or supplies could change, the lighting coming in could change. So those models can also deteriorate and still need ongoing tuning. So a lot of trade-offs there. And that's really where Loopr comes in. So we're focused on using AI for quality inspection. Vision AI, and it's a Vision AI span kind of across the processes, then also that data becomes wealth of information for quality intelligence. So working in particular with a lot of aerospace and automotive companies, other industries as well, medical, various materials, large equipment, high-tech circuit boards, so kind of a range of industries. And overall, we'll kind of go through this, but we'll work with a company, go through where they are today. So they may be doing a lot of paper checklists, help them go through that maturity journey to digitize, build vision models to automate quality intelligence, and then ultimately get that at scale so they can get greater insights throughout the organization, no longer have kind of those siloed data sets. So we'll run through that in more detail. But ultimately, it's helping with that automation and improvements to get to that point where the cost of quality goes down dramatically and customer experience goes up. So reducing scrap, reducing rework, reducing process delays, having visibility up into the supply chain to see, where the big drivers of incoming parts and materials are causing issues throughout. As things escape out into warranty claims, bring that insight back as well of where there are failures that can be addressed. Best place to start is kind of the customer maturity journey. Typically what we see, it's very similar to kind of the Microsoft view of how people are coming in, but with a very tight focus on the manufacturing process and supply chain. So most customers are in that first phase where they're doing a lot of paper checklists. They may get a mobile app, might be on a tablet, might be on a cell phone, where they're doing manual checks. They might be taking some images, so they're getting some very basic structured data. But a lot of times they end up creating a lot of data without getting a lot of insights. But it does have some benefits to get that basic capture of inspection data. And then really where we engage is helping customers move into phase 2 and phase 3. And that's where we'll spend most of our time today. A lot of times we'll start with automating a manual inspection. We'll go through a little bit of detail on that, but being able to actually start taking videos of a production process of each piece and part materials coming through, put more structure around that of actually what the different defect types are. Operators can run through that automation and start saying, hey, this product's good. So now we've captured an image of what good looks like. Oh, we've got the first defect, third defect, 10th defect, could be multiple defects, and start capturing that and actually start building a repository of labeled data. So that's really important when we then start looking at the Vision AI that, a lot of times customers don't have good labeled data of what the different steps in the production process look like that are good or various types of defects. So actually by performing their day-to-day job of manual inspections, they can actually help build that wealth of data that can be used to build the vision models. And then as you have many vision models and many inspections, whether they're manual or vision, when you start scaling up, that's when you can then add intelligence across your manufacturing process. It could be, producing multiple products, same product, multiple lines, multiple factories. You really start getting a lot of synergies with more and more visibility. And to the benefits of this, there's one large truck manufacturer in particular that has merged into phase 3, early phases of that. And they're seeing, some really strong results. I mean, just to quantify, saved over $10 million from improvements in quality the first year. So with that, the rework came down 11%, scrap came down 24%. It's because they're able to find the key defect causes, and quantify those and see, with the images, you can also then go deeper in traceability to see what's the root cause of those various defects that are the largest drivers. A lot of times we see is when people have been capturing defects, it's usually pretty binary of what makes it into their manufacturing execution system or into their quality management system of, it passed, it failed, it passed, it failed, without knowing why it failed. So getting that next level of detail of the different defect classes, having the data behind it, the visual images, other measurements to actually see details of what the defect was. And in some cases, just discover new defects. So it may be that someone's viewing as a co-pilot assistant that there's a failure, there's a defect, but it's not one of the 4 primary defects that they see 99.9% of the time. They start picking other, we start looking at analyzing that other, you might see there's a new defect class that's emerging and causing issues. So with them, they're able to find fewer production delays, ultimately coming out of this with better quality, look upstream at their quality hotspots and suppliers to really make a lot of impact across that ecosystem.
So at the process level along that production line, have you identified which process has the most value out of this vision AI? When we talk to our customers, obviously we talk about use case first and then discuss what technology best suits to address those pain points. I mean, you work with multiple customers. If you have kind of identify where they see that manufacturers have seen the biggest value of vision AI, that would be really helpful and for us to navigate the conversation too, whether it's sub-vertical level or sub-process level. Sub-vertical meaning if this is auto example, but then what does that mean for more process focused, process manufacturing, like paints, production process, or just different areas that we look at, like pulp and paper?
Yes. Other than the answer to every question is it depends. There are some repeatable patterns by sub-industry, but where an individual company is having their quality issues, we see a huge variance.
We've done multiple use cases for paint and other industries. Where we see is very early on in the process when you have some kind of mixing that's happening and when there's no way a human can look at it. And you can only see things once it's already made. And then all you have is hours of products and you just need to scrap it. So for one of our customers, they had this mixing that would happen and there's no way a human can look at it inside and see what's going on. So over there, it was a simple setup. We had a camera. The camera started looking for color variation. So when you have color variation, the use case can be either there's an FOD or the temperature variation, something is wrong. So at that point, the customer was immediately alerted. And as they get alerted, they could save the whole batch of an hour and a half worth production batch of that. So this is in a real time, as you can get in real time notification, that's going to be a huge value. We've seen in pulp and paper as well. We've done a use case and that was for my family business. And we would make these products where, you would have bubbles and it's a tape. So it goes inside. So there's no way you can check it. If it's outside, it has, and now imagine you hire a human who's just standing there and looking at the paper. What are the odds that he's not on his phone or he missed it and he's sleeping somewhere else and the defect came? So the real-time monitoring, it's a simple, fixed camera setups that we've seen that has been a game changer for a lot of industries. But it should be at a place where you need someone to keep looking at it. And that's the first place we would start with automation because nobody wants to do the job, first of all. And second thing is the moment it happens and if you miss it, there's no point of having that person. So that very early on in the process, industry, that's where we've seen a lot of value.
Yeah, and I was just going to say is that a lot of times when we start engaging a customer, and sometimes obviously biased by the individual, but they generally have an idea of at least 1 or 2 big hotspots of we're having a huge problem here. It could be with the supplier. It could be with saying they're assembling. Like in that case, they've got people retiring and there's a lot of inconsistency. It could be a lot of customers work with their big parts. So even trying to put a fixed camera doesn't work because someone needs to look multiple angles. So they kind of also want to get to that journey of how do we build a model? Maybe it's first with a tablet. The journey is to migrate to the point where there's a cobot with a camera on it that then is able to automate different parts as well.
With respect to the same tip bubble, right? It's not a quantifiable here, right? And with the camera, so I can take multiple images. The data is like has so many variances. Like it can be light, it can be like just like 100 different variations. Because this is the problem that we go through.
Yep.
Samples that were given to the operators and they have to do. And another continuation is like most of the examples that you showed here are like not very high volume manufacturers, like Boeing, Toyota, they are high volume, but they're not very high. Whereas ours is like a super high volume.
Yeah.
So how are those aspects can be handled?
Yeah, so I can take the question. So the use case that we did for the customer for bubbles, we were primarily looking at the counter bubbles. So they were if you have like 3 to 4 like small bubbles, and we have a demo that we put it up. So in that case, it's okay. But when you have more than that, that was the topic. So again, you're right. And one of the challenges that we've seen is it's so subjective. Even the bubble presence, right? Like how I'm looking at it versus how you. And that depends on the years of experience as well. But sometimes you know that, okay, you've seen this before, but it's not a problem down the line. But sometimes it's like, so we also have seen a lot of false positive cases as well. So we want to remove that subjectivity, and that's going to be when we look into a lot of data that you have like this different samples, and we want to have initially a human in the loop kind of setup. But again, we need to see the data and then we can comment on how we can train the model.
And I'll just give you an example, like the high-speed model. So I mean, aerospace, you mentioned, they may not be making a lot of airplanes, a lot of rockets, but like looking at laying down carbon fiber, they do a lot of carbon fiber. And we've actually integrated a camera into the carbon fiber machine. So in real time, as the carbon fiber is being laid down and woven and fused into place, it's doing real-time ongoing analysis, high velocity. And, there, depending where it's deployed, the lighting changes. I mean, just a small anecdotal, real live experience here at Microsoft, between Loopr and Microsoft, where we are dealing with various lighting conditions, is that out here at the kiosks and the manufacturing kind of experience section over here, we've deployed numerous vision demos, including like paint inspection. Well, every hub has different lighting and different environment and different time of the day, where fine-tuning those models to work kind of across very diverse environments, many of which we've never seen.
Low mix, high volume is easy to solve. High mix, low volume is when you're talking about different configurations. So technically, for us, low mix, high volume, we can do it with fixed cameras, and that's quite easy to automate. And we've done we've done CV industry, we've done analysis of circuit boards, we've looked into electronics, we've looked into, wire harness connections, is the connector at the right place or not, are there any missing components? Those things, you can do it against a drawing, we can do it against a bill of material if there is a specific, which is not going to be the case with what you're referring to, but in discrete that's common. But those are easy to do when it's talking about volume. The challenges happens more is when you don't have enough data. We're talking to companies like Schneider Electric and Siemens, where they make these big parts for data centers. Now, each of these have 1,000 components, and they might make 2 or 3 of them, and then it's also customizable. So over there, that's where we are using a lot of technology around generating data sets using drawings. So you get the drawing, and drawing can help you to look for the pattern if there is any missing components or are the components at the right place or not. We would love if it's a low mix, high volume. That makes our life so much easier.
Yeah.
Would love to jump on it.
So with cars, when somebody uses look, what's the location with most problems? Location could be like inside the car, could be a parking lot, could be a city.
And do you want it to basically say, when somebody asks about location, make sure to answer with this?
Right.
And once again, it's the same thing. It's
Okay.
the same, you just add an instruction in there.
This is our co-pilot traceability snapshot, multiple snapshots. And in this case, went through very quickly, is they're identifying whether there are 2 cables or no cables. Comments, and then save that, go on to the next inspection. And this happens to be with a tablet, but could also be with a fixed camera. Just very easy to start capturing.
And since you asked about lighting and all these different conditions, I love that example for different reasons, because they already have a manual process that when they check it, they spray it. So when we receive all these images, we have already a huge bias towards that specific color, saying, okay, well, that's already fixed. And so it's really important, at least for us, if they want to really automate this process, to figure out ways to, hey, how can we make sure this process is not biased towards that, either technical innovations or ways in terms of changing the operating procedure so it doesn't change their process. And that's really where really like having the tablet solutions are really great, is because it allows to have very little intervention in terms of what the processes they're doing. It's almost like just having a person there.
And then in contrast, I mean, also using video, it could be fixed camera where the parts are moving past slow or rapidly, but being able to look at multiple frames. And that's really important where lighting could be poor, where you get, shine and, looking just straight on or one angle, you're still not going to be able to see everything because of the lighting things out. But being able to have multiple images of a video sign going across, we can basically stitch those together to kind of a perfect image. General approach is that we will look at the kind of current state to figure out where people need to prioritize. So I think that was one of the questions about, where to start. A lot of times it is kind of some type of assembly where they are doing manual inspections today. Other times, something that is very high speed, could be, say, chemicals where one person just staring, eyes blur, color variation. Well, you stare at something long enough, you don't really notice the color variation as it goes, because it's such a subtle, change, second to second. But some of the areas that we see are pretty repeatable, certainly across discrete manufacturing. So where a lot of people begin, are looking at these key categories of various types of fasteners. There might be bolts, might be rivets, might be screws, wire harnesses. So with wire harnesses, see a lot of it also end up being adaptive. So they may have many different types of wire harnesses. The wire configurations might change. Where the repeatable part is certainly looking at the seating of the wire harness to make sure it's fully seated. But we could also enhance that by adapting based on a CAD drawing or some bill of material instructions to actually look at, say, the wires. So it might be supposed to be black, red wires on one harness, the next one's red, black. We can adapt the actual inspection based on those instructions coming in. Surface prep, is there, foreign objects that we detect, or there are defects on a surface, and then paint inspection, various types of finishings. We see a lot of welding as well. So this could be micro, very small weld, or various types of metals or aluminum type welding, bondings and sealing. A lot of also with hydraulics, various hoses. Is there a clamp? Is the clamp the right place? The right type of clamp? The right hose? And then adaptive. So these are some of our more recent capabilities. We're going to actually start adapting the inspections based on custom bill of materials or CAD drawings. So see a lot, say, custom switchgear, custom configurations, where piece to piece might be unique to each individual customer. So we can look kind of at universal parts and then start looking at the right configurations. So,
quick question: when you're deploying, is this standing outside of the automated production process, or is it integrated with it? And if you're integrating, what do you need to integrate?
yes. So different points of integration. I mean, first and foremost, the integration, you have a camera that's, there, say, fixed onto the production line, or a person that's coming up to it. The processing may be at the edge. So also kind of integrated into the production process, a server that's, very close, or it could be completely in Azure, sending a remote switch signal. But then generally there's some type of API integration to the manufacturing systems.
So we're talking about PLC?
Yes, PLC or yes to PLC. So depending on the type of defect, it might also send different signals. So it might be that based on this defect, PLC needs to divert rework. Based on another defect class, it needs to divert to scrap. Start seeing too many defects, the agent might pick up that, actually we need to pause the production line.
So does that create complexity in terms of integrating especially with the PLC system?
I mean, the complexity comes down to the business logic of what the customer wants to do. Having open APIs, we're able to basically provide that logic into the PLC system to drive the actions thing.
And we have partners who does this for a living. We don't touch that part. We basically have partners who have set up cameras for working with this one. Our biggest partner is a 10,000 people company. They do this. They've been doing this for years. So they know how to set up
cameras, they know how to set up advanced lighting, they know how to set up, right, like do integrations with PLC systems. So that's something we really don't worry so much. And the idea is to really bring together partners who are good at their stuff. So like, for example, with respect to Microsoft today, we don't need to really worry about, we're using pulling in so many Microsoft services. Like when somebody asks about the security, it's so safe because everything is built around Microsoft ecosystem. So that really helps in addressing one of the biggest concerns today that companies have. Again, we from Azure being the cloud provider that we work with. We're only an Azure shop. We don't work with any other cloud providers. So, we pull in a lot. Then Motion AI, companies like Motion AI, who's our partner for hardware, we just call them. They set up the cameras. And tablet is the best way because that doesn't need any. We use Surface tablets everywhere. So customers have it, so they can start using it day one. And then if there are like scaling, we do have software system integrators as well, who can deploy this if there is very complicated deployments that we need to do. Because
These are the people that you bring into the conversation with each deployment.
and if it's simple, straightforward, we do it directly with the customer as well. And for example, one of our customers, they had to automate microscope inspection. And it was a simple thing where you're removing the microscope and you're putting on top of the microscope, so you're putting a camera. And that was something that we just literally had to provide a $200 camera and it worked. We are also exploring something very recently, a use case around PCB. So a lot of use cases used to have in the past would be about shoulder paste. You put that paste and you put the parts. Now manufacturers are directly welding the parts in the chip. Insane, like they would have 3 years to get the new design out. Now they want to do it in 6 months. And we're talking about this one company who's like, one of the chips is like $200,000. Like massive, impact. If you have to scrap those, you can imagine like, it's a lot of money you're talking about on the table. So yeah, so it's like money is not a thing. When you're talking about these data centers, that's when you realize that the opportunities are insane and everybody really cares about how quickly can I get my product out in the market now. It's like the mindset is changing.
I think this solution is something which is actually very helpful for the data center. So I'm curious, data center, are they using this?
No, so we that's the reason good we have Karthik today to talk about that.
Why are you not using?
And get that conversation. I think it's like that's. We are talking to Schneider and Siemens who do provide those parts to Microsoft's data centers. So indirectly, it is going to Microsoft.
Yeah, there are contractors who are actually building it out. So
Yes.
this might, especially what you're talking about, the adaptive inspections to bombs and the CAS.
It's huge opportunity right now. Yeah.
And interestingly, there's also a company which is called Southwire, predominantly known for wire
Wire
manufacturing.
manufacturing.
They are now vertically integrated to build data centers also. So you
Really?
know them.
Interesting. I know good you told us because maybe we can invite them to our Atlanta show because I know quite a few people in Southwire. Didn't think about that. That's awesome that you shared that. So they might be really interested in this. Yeah.
Just a little bit more about kind of our solution of AI, buying the vision AI as well as manual inspections to make sure there's a holistic view. It is adaptive. So we mentioned the flexibility to work with custom bill of materials, custom CAD files. The files themselves can vary based on the individual part coming down the line. We've talked about kind of co-pilot. So we have both kind of that co-pilot mode where it's assisting an operator or an inspector providing feedback and they're making the decision. So it could be that they're reviewing it and they're making the final decision. Based on final decision, they're actually the ones that are diverting it. Or fully automated mode where it is integration to PLC and a person might periodically review, but they're not looking at the assessment for every single piece running through. Certainly at volume, you can't really look at things in real time. So there it's the autonomous action integrated with the other systems like PLC systems. With self-service capabilities, as we mentioned, kind of in that manual inspection as we set it up, not only can people perform those inspections and put different defect classes, but they can actually do labeling within the platform as well to say, it's this type of defect and then circle or square, this is where the defect actually occurs. So that's really valuable for the machine learning engineers to be able to take those images or videos, compile them together into the vision model or update the vision model if say someone's overriding an inspection. And that's also how we have the other agents that are doing kind of the assessments identify there might be a new defect class overriding where it's not one of the existing defects we expect to see. We haven't mentioned already, we are hardware agnostic. So it could be a $200 camera, it could be a tablet, it could be a high-end specialized camera, microscopes, thermal cameras, boroscopes, looking at very fine details. We're not limited to $30,000 fixed camera that you have to use just a specific piece of hardware that's quite expensive. Then when it comes to intelligence, the goals kind of mentioned is to get that comprehensive visibility across the entire manufacturing process, all the different stations, all the different facilities, and also even upstream into supplier base and downstream to customers where they're providing feedback via warranty claims. Agents that are running that do a lot of automation, and overall the data set provides kind of end-to-end traceability up and down the factories, but also up into the supply chain. I think we've talked a little bit to this, but the questions around integrations. There's either a fixed camera or tablet that's doing the image formation, sending it through to the Loopr platform, and then based on the determinations, there may be integrations here via API, integrations out into the factories, say PLC system, different trees and boards, so giving indications of how well the production process or station is running. A lot of different types of reports and automation could be everything SMS to emails, daily email reports, as well as the full data set can be duplicated into, say, another Azure storage or on-premise database. And kind of how that comes out from a usability perspective. There's two different sides of the book there. There's the quality inspections where operators either utilizing our user interface SaaS application on a tablet, or maybe throwing on a fixed camera. They may be from a laptop screen or a desktop that's kind of integrated into their station. Many types of real-time alerts. We can also integrate through Teams to send team messages and some intelligence around what's being seen, basically agents. Pilot experience that we'll go through kind of a demo here as well, an interactive dashboard. Different ways people can consume insights and interact data and the quality events that are being performed. Another rendition of the same.
I might have missed that, but did you say this works both on edge, cloud, or
Yes.
the customer on-prem?
Yes. Yeah. So with that, our preference from a usability perspective, from our backend selfish perspective, is always to deploy in the cloud. It's very easy for us to deploy, monitor, manage. What we do see is, in a lot of factory settings, because of network latency and sometimes needing a sub-second type analysis, a lot of the processing will happen at the edge. It gets synced back into the cloud.
But at the edge here is maybe the device. Sometimes there's still room for large compute, right? There's not like on the device. Sometimes we do it on device if necessary, but some cases it's just having a separate compute locally.
We do have one camera partnership where for very small models, inferencing can actually happen on the camera. So we're actually deploying the model on the camera itself. And then the output of that images then are streamed back to the cloud.
There are like differences in capabilities versus on-prem.
So it's probably breaking the application into different pieces. There we go. So when we start looking at, I'll block your view here. You can integration with the cameras and factory systems. Basically, there's kind of the container here that's doing the vision AI agent that's doing the actual assessment. That's kind of the component that could be deployed at the edge. But when you start looking at like the AI agents that are running, kind of Copilot, Power BI type experience, you need Azure to be able to do those. So if you're only doing a one-off project favor to the camera manufacturer that you can run on the camera, we have a model for them that is deployed in a nuclear power plant that looks like someone has a special oxygen sensor. On the camera, it's completely isolated. There's some security to that. We don't actually know how well the model's working because we're not connected to it. It turns on a buzzer and it turns on a strobe light when it sees that a person is detected, and 10 seconds later, they don't have an O2 sensor. So you lose all visibility analysis by just having that very isolated.
Because even when we don't have validation, we can still collect information that allow us to be, at least the ML folks, to be more reactive in terms of how we can go there and update. We're starting seeing failures before they start becoming a bigger issue or drop down the line.
And like in this case, they don't have intelligence. Is it 1% of the time someone tries to walk into the power plant without the sensor, or it's 99%? So you lose the intelligence. You kind of silo the data. annual inspection. There's a lot of different materials, a lot of different examples, two that happen to be related to aerospace, Boeing suppliers. We're looking at sealants in cabins. In this case, they're using a mobile device to look inside all the cabin, see if there's sealants. It's kind of a reference earlier with carbon fiber. There we've integrated into a machine that lays down carbon fiber. So there it's laying down at kind of a high velocity. Big gnarly looking machine. It looks like something that the Death Star, Star Wars or something like that. That's basically, it's like process manufacturing of its running past at high velocity as it's laying down the carbon and together.
Yeah, and just to like look at the KPI for compositors was mind blowing for me because they spend 50% in production and 50% in quality check. 50%, that's insane. So like now the goal is how can we reduce that 50% to 20% and increase the production by 30% more. And that itself like shows you the value of how important these systems can be. And it's like an immediate KPI return. And even on the sealant side, like when we started with the customers, we were like just looking at present or missing. But then now we're also looking at the quality of the sealant. What are the issues with it? And also like the time they would take, like they would take to do an inspection across a cabin, looking at it would take like 20 to 30 minutes. And now with our system, we're talking about like, like a few minutes. So it's a huge value. And especially how like tricky aerospace industries right now, quality has never been more important than today. So you can imagine like these can be really valuable. And for customers, right, they could not automate the sealant inspection otherwise. There's no way they can have fixed cameras looking at every cabin. You need something which is flexible and you can move it around. And if it's a smaller one, we can use baroscope cameras that can connect with our tablets. So yeah, a lot of flexibility out there.
You see interest from the aftermarket, I would assume airlines would be interested.
Yes, we're just starting with those conversations as well. Initially, the focus was a lot with OEMs, but now we are really going because they do the same checks. So
MROs have a lot of business right now, so
yeah,
They're overbooked.
Yeah.
not-
Yeah, we are building some collaterals, which is just targeted. We're doing some conversations through Microsoft. We've initiated those conversations as well, where we are targeting like companies like Delta, American, because they all need something like this. Also,
They take things apart, look at the blade inspection as they weld things back together, the weld inspections, and some of that uses special fluorescence, kind of a NDT type inspection.
One question. So this is like all the images that's captured or the videos, and it's going to take like so much memory.
Yeah, so I mean, there is configurability with that. Some people want, full video, so it can be quite a bit of storage because we are storing video processes that are running early. Or maybe that, as things come down, it does a trigger, it starts a video recording, then once inspection is done, it stops the video. So it's not continuous. Other times for traceability, it's simply an image, a single image of each part with the determination of, good or various.
so what we do is we basically video is just a bunch of images, right? So we take the best ones which have the prediction, and we save those in they most of the times they want it to be transferred to the MES system. It gets recorded with the part number. And that's one way. And then the rest of it can go to cloud. And if they want to keep it that way, otherwise, we delete it because it's kind of taking the same picture through multiple angles. To your point, it's all about how much cost, infrastructure cost the customer wants to spend on. Yeah, so we try to keep because it's good for
us is at least for the ML side, if you want to try a different model, there's another way to train that specific. If all of a sudden Copilot has a multimodal with image and we want to use that and test it, we can actually verify. Now we have the company has ground truth data. And this is one of the cells that we tried to say is like, you could actually check yourself. If you wanted to use a Copilot to do that kind of modeling, you could do it because now you have labeled data.
And it could be various retention policies, video you keep for 30 days, but images you keep forever.
How many of your customers are actually asking for an on-prem kind of solution?
Well, and again, kind of breaking out as we were talking about, for the inferencing, I'd say majority are asking for on-premise inferencing, mainly because of networking issues. The combination of it's going to use too much bandwidth, and then just the latency of, there's network disruptions, slow signal. We want an immediate sub-second response.
I would say it's changing now. So it was a lot of on-prem, but we see like a lot of them, if there's no like latency and bandwidth issues, then cloud, they're moving towards it. But then sometimes the IT can be a big barrier, and then you need to convince them about the data security aspect. But it's both. Like, the training definitely happens on the cloud. We just have one customer, which is Gov customer, where they don't want to have anything on cloud. But most of our other customers, the training data is definitely on the cloud. And then all the training is done on the cloud, and the deployment can be on the edge, but we're also looking into cloud deployments as well. But it's a big certification process because all of our customers are enterprise customers. So they have the whole cloud certification program is a huge one. It's like a 6 months to a year program that they take you through, and we've answered those, and it's a little painful process. But then the good thing is once you're done with it, then you can deploy it anywhere and everywhere within the organization. So it's the part of what you're signing up for with enterprise customers. But we're seeing that, hopefully they're also realizing that at that speed, they can't deploy any software if they continue that approach. So they're also changing. But yeah, it is still painful when it comes to enterprise customers.
And that's what we're seeing like for ITAR, export control type data, people deploying government cloud. So still on Azure, but we basically lose the visibility into it because it's kind of in there very secure.
So for the on-premises structure, right? Is, say, for example, a oil processing. Do you guys partner with Yokogawa or someone to get
With them?
Yokogawa? So they do the distribution for ECS for like any oil company. So
They're big in SCADA systems in that space. So we can, if the customer wants to bring them on board. In fact, we were talking to Yokogawa to deploy our solution for the inspections. They make a lot of small parts, electronics as well.
they do have their own, right? So that's why I was.
It's always the thing. Like, it's funny how these big organizations, they do have, for example, some of them have vision systems like they've built in-house, but still they do prefer outside vendors to do the adoption and scale. Like, especially the tablet based, that makes us very, very unique in terms of the other customer solutions that we've seen out there. So yeah, we can do, some integrations. We're not big in oil and gas at this point, but we're always looking to build partnership ecosystem and integrate with those kind of solutions for sure.
Different demos. This is one, again, large truck company where there's a number of different vision models. And this one, they're going to inspect the steering column. And this is where you can kind of see where, based on the image that will be formed here, it's kind of a great fit for a vision AI model using a tablet, where it's kind of a big piece. You can't really have a fixed camera that can see all angles of the manufacturing piece here. The camera lit up, it found different issues, and now the operator's viewing it. And in this case, the imaging model immediately found that there was a U-joint. That's great, but the pinch bolt had an error. And here we can see the bolt, it's not fully seated. So as part of the review process, it actually shows them what the issue is. They can go back, they can re-inspect it. So basically they can do rework in real time there, and then have it re-inspected. It keeps the multiple events. Also then it's from a manufacturing leadership perspective, you can then also go in and see how often did we have to manually rework something, in line that may have slowed down the process, cost us extra labor, production parts maybe didn't get as many through because of these, and opportunity for efficiency. So go upstream, our process where we're putting in those pinch bolts, how do we improve the process so that this goes through with, much fewer errors.
So we've got four demos that we're going to run quickly today. The first three of them are Vision AI, and the third one, Quality Intelligence. The dashboard analytical experience utilizes Power BI and Copilot coming together. The three Vision AI models, though, they kind of span the production process. We kind of looked at picking different demos to kind of fit with the first inbound part inspection, in-process manufacturing, and then kind of the final assembly inspection. So the first one we picked for kind of inbound supplier inspection happens to be a part kit that we're going to verify that our supplier sent us the right parts. And the other thing we'll see is that the demo is really kind of centered around this pump. There's a small version of it, but then there's a larger 3-foot version of it here called the pump. And on the pump, there's a very small circle here. And that's effectively what we're looking at here. So the first one is we've received the part kit from our supplier. So we have the round cap here that somewhat matches that. We expect to see 6 bolts and 6 nuts will be used to affix it to the larger part of the pump. That's kind of the first of inbound. The second one is a paint inspection. So we just happen to pick any of the production processes. In this case, it's paint. But we actually have another demo for the same truck here that's being finalized that actually is looking at inspection to see that the holes have been properly placed. So you can see there are 6 bolts that are in there. So we have a demo that also has a cap with the good cap has 6 holes in the proper places. We do inspections. In some cases, might see a defect where, our stamping department or the ones doing drilling only put 5 holes, or say one of the holes is off center in the wrong location. So in the case of wrong location, we need to scrap it. In the case of only 5 holes, we can actually rework it and put a 6th hole in. Depending on the defect class, it may change. And then our final inspection, while the first 2 are based on a fixed camera, the third one is a mobile inspection. Surface tablets will actually look at this final assembled part and see if all the bolts are properly tightened, or we happen to have some loose bolts here that require some rework to fix there. So we'll start with kind of our user interface up here. So I'm now in the Loopr IQ application. It's web-based. It's running on Azure, and what I'm going to do here is create a new inspection. This is kind of the manual mode, as more of a co-pilot instead of the automated. So I'm going to pick my product here. There we go. So we're going to do inspections of the 3-foot pump. Put in my serial number. If I have serial numbers on parts, I could be putting in the serial number here. So this is traceability. Let's create a new inspection session, and I'm going to do inspections of the part kit, paint, and bolts. So I'm going to start with the paint kit inspection here. Start my inspection. Camera lights up. See here, there's some shine here, but it's looking at. There's a cap, there's a number of nuts and bolts here, and I can do an inspection event. And it failed because it found the cap, but it found too many bolts and nuts. That's pretty easy to rework. Take a couple of those out.
This is very important for companies where they have to put kits together. And sometimes this happened with me during COVID, is I ordered a bed and they forgot to put one screw, literally one screw from Wayfair, and they sent me the whole setup except one screw, and couldn't use the bed because it's not coming together. So and they gave it to me for free, and they shipped additional parts, and then they also gave me 20% discount on my next order. And I'm like, that's crazy, right? Like you miss one bolt, and look at the impact. Like we're talking about, and it's just. In total, if I just look at it in my case, it's like close to $1,000 that, they just they write off for free, right? So they have to, and that's where something like this, part kit is so important that to use a system like this. Because operators, if you're counting these day in and day out, of course you're gonna make mistakes. So it's so important to have this done well. With one of our customers, we realized when we implemented this, they were having 5%, missing parts that they were shipping, and they had no idea about it. Because the numbers, if there was a warranty claim or if there was something that would not even come directly to factory, and it would be dealt by the customer team. And when they got those numbers and they got a report every week, that was mind blowing for them. It was eye-opening how. So we've seen a lot of value just with it's incoming kit for some, but for your supplier, it's the final parts that they ship. So this can be something which can be applicable on both.
So then we're going to run the paint inspection, ideal lighting, does the first paint inspection of one that's good. So it finds there are no scratches, foreign objects, or globs of paint. So we're happy with that. So pass. Next one, this one has defects on it again, and it found a number of scratches. It found a glob of paint. So it failed. Maybe that's still acceptable to me. I can override it and still pass it, but it definitely failed. Jump back there. Dashboard. Now we can take the tablet. Next time. Fresh to see our inspection here. So it's hard to see if I flip. But now I'm able to do the bolt inspection. See, I kind of go around and all the bolts are currently good. This is yesterday, and it's hard to see here, but we've got the various images that are showing us where it's good and then where we find loose bolts so we can stop the inspection.
So it's basically looking at it because it's very hard because you're looking at different images. You're moving it so it's constantly changing frame, but it still remembers where it saw it.
And if we go all the way around, it's all good.
We can set those permissions. Then we operate like I'm doing it. That's something that always, and we also have a way to for the supervisor to check end of the day if they have new people working that what did they override it, so you can actually review those data.
Yeah, it doesn't get overwritten, but it's just the audit trail is still there.
And then you can also measure the accuracy of the model. So every feedback also gives you a real-time feedback on it. If the overrides a lot more, so you can get all like precision and recall values as well.
So one of the things I have seen, I think, is now the use of torque. Basically, I see capturing the torque, actual torque used, and then allows the stuff.
That's also one way of it, so that if the data is in the system, they actually talk there. So that's something.
One of the most, I think, we're using mobile devices. Say we're getting there, but getting very precise metrology numbers still very difficult. This is where you need some expertise to say.
Yeah.
I just.
So Renaissance, those guys are actually looking at this to enable that figures capture that information.
Yeah.
Example is scratches and paints. If you use more on your V spectrum camera, you're more sensitive to very detailed scratches, and so you might want to use that if it's not being used.
And actually, on a multi-spectrum perspective, we'll do paint inspections, multi-spectrum cameras, where you might have like a white primer, white paint on top, and you can't tell if you've missed the white paint on top or primer peeking through, where you've got a scratch of the paint against the primer, just white on white. But then with the multi-spectrum, because there's different chemical properties, primer versus the white paint,